So we're going to be solving paper 1 chemistry CIA examinations, and the topic for today is going to be alkenes. So let's get started. First, we're going to solve the questions that include both the core and the extended candidates, and then we're going to do for the core. I'd like that if the extended candidates, they also practice the core stuff, right? You have to do both. Which formula? And before starting, I'd like to tell you guys one thing, that you have to put in the work and the effort to get the result, right? I know many of you are just gonna skip after watching 1-2 questions. You have to solve each and every question, past papers and everything to get the result. Which formula represents an unsaturated hydrocarbon? The first thing over here is the word unsaturated. Unsaturated means that the valency of carbon is fulfilled, but there's a problem. There's a carbon-carbon double bond. That is unsaturation. That means carbon is not happy with this. Why? Because it's not fully saturated with its neighbors. So full saturation means that all bonds are 1, 2, 3, 4. All bonds are single. That means fully saturated. But unsaturation means that there's a carbon-carbon double bond. So we're looking for double bonds here. Which formula represents unsaturated? Now I'd like to tell you guys one other thing over here, that alkanes are saturated hydrocarbons, and the general formula of alkane is CnH2n plus 2. And this general formula, if in place of N I put a 2, for instance, it's going to be C2H 2 times n was 2, 2 times 2 is equals to 4, plus 2 equals to 4, 5, 6, so it becomes C2H6. That's the formula for ethane, right? The hydrocarbon, an alkane that has 2 carbon atoms. But if I make the general formula for an unsaturated hydrocarbon that I'm going to consider to be CnH2n, if I consider N to be 2 again, it's going to be C2H 2 times 2, C2H4. Well, that's the general formula for an alkene, and this is your ethene. So now you can see one thing over here, that in alkenes, the hydrogen atoms are going to be double of the carbon atoms. So when you have unsaturated hydrocarbons, you're basically talking about alkenes in this level. And when you deal with alkenes, you're going to double the carbon atoms to make the hydrogen. So over here, when we're looking for an alkene, instead I make the formula for every other hydrocarbon, I look for double the number of hydrogen, because I know in alkenes it's going to be double. The hydrogens are going to be double of the carbon. So if I start with my last option, C5H12, no. For unsaturation, I need C5 and H10. I need the hydrogens to be double of the carbon. So wrong. C4H10, again wrong. I need C4H8. Why? Because I need the hydrogens to be double of the carbons. Next, C3H8, again wrong. I need C3H6. I need hydrogens to be double of the carbon. Next, C3H6, that's correct, because hydrogen is double of the carbons. 3 plus 3, you double it and it becomes 6. So option A is the correct option. The structure of an organic compound is shown. So this is your organic compound. Now there are a variety of groups you can see over here. First, you can see unsaturation over here, a carbon-carbon double bond. Secondly, you can see a carboxylic acid functional group. I believe that's pretty visible. See, the style of writing is changed. Examiners just made it a bit stylish like this, but you don't have to get confused. You cannot consider this to be an alcohol. You have to keep in mind this at the top. So this is a carboxylic acid functional group. The compound is tested separately with thymophthalene and with aqueous bromine. Now you should know one thing, that thymophthalene is an indicator. An indicator has colors in acid and bases, and over here this is an acid group. So you have to learn that thymophthalene is basically colorless in acid, and blue in alkali. So for acid, it has to be colorless, because we have an acid functional group over here that you had to identify. The second thing is aqueous bromine. You should know this unsaturation over here. And if you're going to add bromine single bonded to bromine, so basically this is Br2, and that's the bromine that you see in orange color, or you can say reddish brown color, whatever color you see. So basically this is your bromine, and you're going to add this bromine to the C double bond C, and let's just put the hydrogens over here as well. These are your hydrogens. Now the problem is that when this bromine is going to enter this compound, there's a double bond here. This double bond just needs to break. Why? Because this wants the carbon to have saturation, like 4 single bonds. So what's going to happen, as soon as this bromine is going to enter, this fella is going to break from here, and then this bromine is going to attach here, and this bromine is going to attach here. So this is what's going to happen when you're going to add bromine to a carbon, double bonded carbon, or an unsaturated hydrocarbon. Okay, got it? The bromine is going to turn colorless from your orange, brown, whatever that color is. It's going to turn into a colorless thing. That's going to make this thing the correct one, right? Ethene is a hydrocarbon. Yeah, we know ethene is a hydrocarbon. Why? Because it has a C double bond C, and then there are hydrogens that are surrounding it. Which row shows the type of covalent bond? The type of covalent bond between carbon atoms in ethene and the effect of ethene on aqueous bromine. The type of bond is a double bond, right? We're dealing with ethene. We're not dealing with ethane. Ethene means there is an unsaturated part over here. So it's going to be a double bond, and effect of ethene on aqueous bromine. We just saw that whenever you have bromine and you're going to add an alkene to it, an alkene is an unsaturated hydrocarbon. You're going to add it to it, it's going to turn from orange to colorless. Color changes from brown or orange to colorless. That is correct. Why does it change to colorless? So because this bromine bond that was previously here broke. This bond was making the bromine orange. When it broke and one bromine got here, one bromine here, it turned colorless. You formed dibromoethane. Ethene and propene, both members of the same homologous series. That's the alkane series. Ethene is C2H4. You double the hydrogens, and propene is going to be C3H6. You double the hydrogen. Which statement explains why ethene and propene have similar chemical properties? They are both hydrocarbons. They're both made by cracking. They have similar functional group. Okay, they're both hydrocarbons. Now, I know these statements are always confusing for people, but I'd like to just tell you guys one thing. Okay? Ethene and propene are hydrocarbons, right? And they're alkenes. Good. And then you have ethane, that's an alkane. Got it? They're both hydrocarbons. Alkanes are also hydrocarbons, but alkanes don't have similar properties to alkenes. That means the hydrocarbons don't have similar properties. The same functional group, the C double bonded C, makes the ethene and propene both react with bromine. Why? Because they're both unsaturated, whereas ethane and propane are not going to react because they're saturated. It's not the hydrocarbon thing, because alkanes are hydrocarbon, alkenes are hydrocarbons because they have carbon and hydrogen only, but they don't have similar properties. Only all the members of the alkenes have similar properties. All the members of alkenes have similar properties. So hydrocarbon is no guarantee, and they're both made by cracking. By cracking, you can make both alkanes and alkenes, right? You can make anything by cracking if you take a large hydrocarbon. So no. The functional group is related to chemical properties. Always remember. So it's going to be 3 only. The functional group reacts in the reactions. Always in alcohols, carboxylic acid, nothing happens to the long chain. Only the functional group is going to be the reactive part of a compound. A molecule of compound P contains 2 carbon atoms and 4 hydrogen atoms. Which row represents P? 2 carbon atoms, 4. You can make sense out of the things. I told you that in alkenes, the hydrogens are double of carbons. So if you have C2, then H is going to be double of it. That's 4. And that's the general formula for an alkene, because the general formula is CnH2n. Hydrogens are double. So that means we're dealing with ethane. And what's the MR? The molecular mass. C2. That means 12 times 2, because 1 carbon is 12, plus H4. That means 1 times 4. 12 times 2 is 24, plus 4, that makes it 28. Reacts with aqueous bromine? Yeah, it's going to react because it's an alkene. All alkenes, either they are 1 double bonded alkene, 2 double bonded alkene, all alkenes that have unsaturation, that have a double bond, are for sure going to react with your bromine. So reacts with aqueous bromine? Yes, it is going to react with aqueous bromine. Next, The equation representing the reaction of a hydrocarbon with water is shown. Okay, CXHY water, what's happening is that you make an alcohol. Now look at the reaction. Try to remember what's happening. You had an alkene, remember? And then you had steam. And whenever you added steam to your alkene, you made your alcohol. Hydration of alkenes, that's what we're dealing with. So over here we have hydration of alkenes, and the catalyst over here was H3PO4, phosphoric acid catalyst. You remember? And then we used to use 300 degrees Celsius temperature and 60 atm pressure. What happened was that initially you had an alkene. Let's take ethene for now. You had an alkene and then you added water to it, which was HOHH, and then what happened was this entire thing got copied over here, but with something new. That was your double bond broke, and the OH part attached to one carbon, and the H part got attached to the other carbon, and two new bonds over here formed, and this made your ethanol. From ethene you can make ethanol, from propene you can make propanol, from butene you can make butanol. You just need to add steam into it with the proper conditions, the catalyst, the temperature and everything. So what is X? X is gonna be, if X is 1, no, there is no methene. Methene is not possible. Why is methene not possible? Why do alkenes can never have a single carbon? Because how are alkenes formed? Alkenes are formed if carbon double bonds with a carbon. If you have one carbon atom, it cannot make a double bond with another carbon atom. That's why alkenes are always going to start with two carbons. Methane, the alkene with one carbon, is impossible. Why? Because for a minimum, you need two carbons to make a double bond between them. So one carbon is not possible. It's definitely going to be two, and if it's two, then your hydrogens should be double, because in alkenes the hydrogens are double of the carbon atoms. A large hydrocarbon undergoes cracking. Cracking means you have a large chain, you break it down into smaller hydrocarbon X and a gas are the only two products. Oh my god, you're forming a gas in cracking. Always remember, whenever you're gonna crack things, there are two possibilities. There are three things you can form. Either you can form an alkene plus an alkane, okay? Either you can form this, or you can form an alkene plus hydrogen gas. There are only two possibilities. You cannot form an alkane and hydrogen gas. It's impossible. Why? Because if you balance out the numbers, you're going to realize that always, either it's an alkene or alkane, either it's an alkene or hydrogen gas, but it can never be an alkane and a hydrogen gas. Got it? So over here, I think if it's a gas, then we're dealing with an alkene and hydrogen gas. Hydrocarbon X, we're dealing with alkenes, right? If we're dealing with alkenes, then we're looking for unsaturation. And obviously, we're cracking, and I told you the only gas you can release in cracking is hydrogen gas. Next, the structures of two hydrocarbons M and N are shown. Which statement are correct? So for M, we realize that firstly, it's straight chain. Secondly, I can see a double bond here. I can see unsaturation. But for N, I can see a straight chain without any unsaturation. If I name this thing, the double bond is first, second carbon. So this is but, because in total I have 1, 2, 3, 4 carbons. That means but. The double bond is on the second carbon. So it's butene. And then for the alkane, I have 1, 2, 3, 4 carbons. And that makes it butane. Okay, M is an alkane. No, M is an alkene. Why? Because this one is going to be alkene. It has this unsaturation, and this one is going to be an alkane because it has saturation. M is an alkene. No, N is an alkene. Oh, sorry. I just messed up a little. Like, you have to be careful that M is an alkene. Yeah. Sorry, I read wrong. And decolorizes aqueous bromine. Yeah, that's correct. This one is an alkene because it has this bond, and it's going to decolorize bromine because of the bond. Now we're moving to the extended questions only. For the extended candidates, which statement about the reaction of ethene and steam are correct? We just discussed it right now, that what happens is we're just going to copy the stuff we made over here. This is your ethene. this is your ethane, this is your steam, and this is your ethanol, and the conditions are 300 degrees Celsius, 60 atm pressure, and H3PO4 as your catalyst. You have to learn this stuff, okay? So what do? We copy this stuff, and then what do? We paste the stuff over here. Yeah, okay, let's paste it here. The product has higher molecular mass than ethane. Well, let's calculate it. The product is ethanol. I think that makes sense that if it's ethane, right? If it's ethane, we don't have the oxygen. If we eliminate the oxygen, this is going to become ethane, right? I think that's what makes sense. So obviously ethanol is going to have more mass than ethane because ethanol just has an extra oxygen. The product has higher molecular mass than ethane. Well, that's correct. The product reacts with aqueous bromine. No, the product does not react. The reactants react with aqueous bromine. Reactant has a double bond, so it's going to react with bromine. But the product is ethanol. It's not going to react with bromine. The number of electrons shared between carbon atoms decreases. The reaction produces an alcohol and hydrogen. No, only alcohol, and the number of electrons shared between carbon atoms decreases. Initially, the two carbon atoms here are sharing how many electrons? Okay, so over here we have 4 electrons being shared. 2 electrons in this bond, 2 electrons in this bond. Over here in the product, we have only 2 electrons. So the electrons are moving from 4 to 2. Well, there's a decrease. So 1 and 3 statement make sense to me. What is the structural formula of a compound formed in the addition reaction between propene and bromine? So we have propene. Propene means that you have carbon double bonded to carbon, and then you have a single carbon, H, 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 and H. And then you are going to add a Br, single bonded Br. And now what's going to happen is that this bond is going to break from here, and then this bromine is going to move here, and this bromine is going to move here, and this is what you form: 1,2-dibromopropane. Why is it 1,2-dibromo? This is carbon 1, carbon 2, carbon 3. Bromine is on the first carbon and on the second carbon. That makes it 1, 2. And then di means 2 bromines, bromo means bromine, and propane means that you have a 3 carbon flat chain. So if we try to make the formula, it's sorry, there was a hydrogen previously here. It's going to be CH3 CHBr, CH2Br. That is correct. CH3, the CH3 is this part. CHBr is this part, CHBr, and then CH2Br, this is this part. Got it? The pink part corresponds to this, the green part corresponds to this, and the red part corresponds to this. The structural formulae of 2 hydrocarbons are shown. Which statement about the hydrocarbons is correct? So what you can see over here is that this is straight chain 1, 2, 3, 4 butane. Straight chain butane, H, 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 C, H, H, C, H, H, and then C, H, H, H. That makes it butane. But let's look over here. This stuff is CH, H, H, and then it's going to be CH, and then CH, H, and H, and then it's going to be CH, H, and H. So this thing is methyl propane, right? This is propane, and this is the methyl part. It also has 4 carbons, but it is a structural isomer of butane. So butane and methyl propane are structural isomers of each other. This thing is your methyl propane structural isomers. Which statement about the hydrocarbon? They're both alkenes. No, they both decolorize bromine. No, none of them would decolorize bromine because they're alkenes. Decolorization happens in alkenes. Their structural isomer is correct. Why? Because this one right here is a flat chain and this one right here is a branching. Okay. Now we just have a few questions left. What are the structures of the products of the reaction between propene and bromine? We've done it so many times that you are gonna add bromine. Okay, over here, if it was a double bond, over here, if I consider it, then one bromine and it broke, one bromine should add on this carbon and one bromine on this carbon. So this is incorrect. This is also incorrect. How come bromines attach and still the double bond don't break? This one is correct because there was a double bond here, and when the one bond broke, one bromine got attached here and one bromine got attached here. C is the correct answer. Propene C3H6 reacts with bromine in an addition reaction. Which structure represents the product of this reaction? Okay, again, what do you have to do? Both bromines can't attach on a single carbon because it has to attach between the carbon-carbon double bond. When the double bond breaks, one bromine on one carbon, the other bromine on the other carbon. It can't be that there is a double bond between only one carbon. It's not possible. So both one carbon bromine, one carbon, both bromines, no, on two different carbons. This one is correct. Two carbons that are next to each other. Now you might think over here as well it's between two different carbons, but how come it's possible that there's a double bond between the first and the last carbon? It's impossible, right? Because the bromines are going to attach where the double bond breaks. How come it's possible that it's between the first and third carbon? Either it can be between first, second, or second, third, right? It can't be between first and third because they're not connected to each other by any means. Next, some properties of a colorless liquid L are listed. Okay. L boils at 65 degrees Celsius. Good. When added to water, two layers form which do not mix. It does not mix with water. It cannot be an alcohol. Alcohols always mix. It cannot be an acid. Acid always mix. Matlab sometimes. It does not react with sodium carbonate. It definitely cannot be acid because acids react with carbonates to form carbon dioxide. It has no effect on bromine. If it has no effect on bromine, then it cannot be an alkene. Hexene is an alkene. It has to be hexane. Simple by elimination. We found out ethene reacts with water under suitable conditions. We just learned about this steam reaction of ethene and water to make ethanol. Which statement about the reaction is correct? The product of this reaction is MR of 46. We're going to calculate for ethanol is C2H5OH. So 12 times 2 plus 6 plus 16. 24 plus 16 plus 6. That's 16. That's 46. Yeah, that's correct. The reaction produces two different products. No, bro, it's only ethanol. The reaction occurs when ethene gas is bubbled into cold water in the presence of an acid catalyst. Yeah, acid catalyst, the reaction is redox. No, it's not redox. And with that, we're done. Why is it not redox? Because look at the oxidation states. None is going to change. Not even a single one.